Hello everyone. In this video we're going to be dealing with a quadratic equation. We have x minus y squared equals 6xy, and we're going to be solving for x over y plus y over x. This basically means that we are supposed to evaluate the ratio of x to y and then flip it and add it to the original. Alright, I'll be presenting a couple methods, probably two, and let's start with the first one. Now, since I am looking for x over y or y over x, it kind of makes sense to replace x over y or y over x with something. Which one would you pick? Let's go with x over y. In this case, it doesn't matter, but let's go ahead and call that t. This basically means that x over y equals t, and that implies x equals yt. And that's something we can substitute in the original equations. Let's go ahead and replace x with yt. That's going to give us yt minus y squared equals 6 times x, which is yt, multiplied by y. Okay, what is yt minus y? You can go ahead and factor out a y and square separately like this. And this is going to give you 6y squared t. Okay? Does this make sense at all? Now, we have y squared on both sides, which is nice, so that we can just get rid of it. But one condition that we need is y does not equal 0. Why? Because if y is equal to 0, obviously x over y becomes undefined, so you don't want that. So under those conditions, we can divide both sides, divide both sides by y squared, and that's going to give us something simpler. From here, we get the following. T minus 1 squared equals 6t. Let's go ahead and expand this. This is going to give us t squared minus 2t, or not 2t, plus 1 equals 6t. If you are a tutor, then the person you tutor is your 2t. Anyways, let's go ahead and put everything on the same side and come up with a quadratic equation. That's why I call this equation quadratic, because it is. Now, it's quadratic in t. Remember, we had two variables. That was a homogeneous equation. Therefore, you're allowed to reduce the number of variables. That's what's really cool about these homogeneous equations. And remember, we also have them with differential equations and some other scenarios. Anyway, so this is the equation we get. And remember, t is equal to x over y. So that's what we're going to find. Now, let's go ahead and solve for t values by using the quadratic formula. You could also complete the square here. Doesn't matter. Negative b plus minus the square root of b squared, which is 64, minus 4ac, which is minus 4. And then we're going to go ahead and write this in the simplest form. How? 64 minus 4 is 60. And now 60 can be written as 4 times 15. Therefore, when you square root it, you're basically going to get 2 times root 15. Makes sense? If you square root both sides here, that's what you're going to get. All right. So now we can write this as t equals 8 plus minus 2 root 15 divided by 2. And this can definitely be divided by 2. That gives us 4 plus minus root 15. Here's the $1 million question. Which one is the answer? The answer doesn't matter. You can use both, because the sum is symmetrical, right? X over y plus y over x. So it doesn't matter which one you use, because it's going to give you the same sum. In other words, if they ask for the x over y only, then of course you would have different values. But in this case, it doesn't matter. So we can take t to be the positive one, and that would be x over y. And then y over x, if you think about it, y over x is just going to be 1 over t, or 1 over 4 plus root 15. And if you multiply this by the conjugate, which is 4 minus root 15, top and bottom, you would get 4 minus root 15 divided by 1, or just 4 minus root 15. In other words, 4 plus root 15 and 4 minus root 15 are conjugates, and their product is 1, which is nice. They're also reciprocals, not just conjugates, but they're also reciprocals. Make sense? So if this is x over y, then y over x is just going to be this one. So what is x over y plus y over x? That's going to be 4 plus root 15 plus 4 minus root 15. And root 15 cancels out, leaving us with 8 as the answer. And again, if you use x over y as 4 minus root 15, then y over x is just going to be the reciprocal, which is also the conjugate of this expression, and their sum again is going to be 8. So this sum is constant for this quadratic equation. Why? Let's see why in a little bit. Okay, now that's going to bring us to our second method. Obviously there is definitely more than 2 ways to solve it, and I could probably present as an alternative, which I'm not going to go over, but let me just tell you how you can proceed with that. You can take the square roots of both sides from here, because you have a square. If you square root both sides, you have to consider 2 solutions. That's going to be like a plus minus sign, but let's just go with the x minus y equals square root of 6xy, which can be separated like this. And then you can basically divide both sides by y, and that'll do the trick. And after you divide by y, you're going to get x over y minus 1 here. And on the left-hand side, obviously, this is going to cancel out and leaving us with a square root of y at the bottom. And that can be written as this. And then you can go ahead and use substitution, call this something, or this one, and then go from there. Make sense? That's not the second method. I just wanted to talk about the third method without going into too much depth. Anyways, let's continue with the second method. So our second method involves the following. Let's go ahead and rewrite the original problem. X minus y squared is equal to 6xy. And we're looking for x over y plus y over x. All right? Let's go ahead and expand the left-hand side, because why not? X squared minus 2xy plus y squared is equal to 6xy. And then, of course, as usual, we're going to put everything on the same side. This should kind of look familiar to you if you think about the first method and the quadratic we came up with a slightly different approach. This is, first of all, quadratic in x and quadratic in y. So I can go ahead and solve it. So how can I solve it? I can basically write this as x equals, because basically, and I probably need to tweak it a little bit to make it look more like a quadratic in x. So I want to write it like this so that you can see what I'm getting at. And I think this is going to be the constant term, which is y squared. Okay, so the idea here is this is quadratic in x. So the coefficient of x squared is 1, the coefficient of x is negative 8y, and the constant term is y squared. Y is considered a constant because this is quadratic in x. Make sense? Let's go ahead and solve it using the quadratic formula. Negative b plus minus the square root of b squared minus 4ac. Again, that's going to give you the same numbers divided by 2. And this is going to be square root of 60, which is 2 root 15 with a y. That's going to look like this. And of course, I can go ahead and factor out a y and then kind of divide by 2 and simplify this expression. And guess what? At the end, you're going to get the exact same thing. If you divide both sides by y, you're going to get x over y equals 4 plus minus root 15. And again, their sum is going to be 8 all the time. All right? And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.